Newton's law of cooling, an example of separation of variables. A cup of coffee is served at an initial temperature of 96 degrees Celsius in a room with a temperature of 22 degrees. When the coffee reaches 70 degrees, its rate of cooling is 1 degree per minute. How long after serving does the coffee reach 70 degrees? We can solve this problem using Newton's law of cooling, which states that the rate of heat loss of a body is directly proportional to the difference in the temperatures between the body and its surroundings. In order to solve, we can separate variables by getting temperature on one side and time on the other. To do this, we multiply by d little t, which is time, so that time is no longer on the left side. Now, divide by the temperature minus the temperature of the surroundings to get all temperature variables on the left side. We can then integrate the left side with respect to temperature and the right side with respect to time. This leaves us with the natural log of the absolute value of temperature minus the temperature of the surroundings equal to a constant of proportionality times t plus an arbitrary constant. Taking this result, we can exponentiate each side so that the natural log cancels. Using properties of exponents, we can convert the right side of the equation to a product. E to the c is still a constant, so we can rewrite it as c. Due to the absolute value in the problem, we have two cases. The first case is cooling. This is the case that we will need to solve this problem. For cooling, the temperature of the coffee is greater than the temperature of the surroundings, so the difference between the two temperatures is positive. This means that the absolute value is not needed because it does not change the value. With rearranging, we get a formula for cooling. If instead we had iced coffee, we would have a negative temperature difference, giving us a slightly different result. At this point, we have successfully applied separation of variables. In order to solve our problem, we must now use the initial conditions supplied in the problem. The rate of cooling dt is 1 degree Celsius per minute. Because the temperature is decreasing, we can express this as -1. The temperature of the coffee is 70 degrees. The temperature of the surroundings is 22 degrees. The only variable left is k, which is our proportionality constant. We can solve for k and then apply that in the problem. Using our formula for cooling, we can substitute in our initial conditions and a value for k. At time equals 0, the coffee is 96 degrees. The exponent becomes 0 and e to the 0 is 1. We then rearrange to find that c equals 74. We can substitute back into our equation one last time and then rearrange. We subtract the 22 and divide by 74. We can then take the natural log and we are left with t equals -48 natural log of 48 over 74. This negative sign is just an exponent. We don't actually have negative time. It makes the natural log positive. We can continue to rearrange in order to get an exact result that t equals 48 natural log of 74 over 48 minutes. This is approximately 20.78 minutes until the coffee cools down.